and this one is our charging section. As I show you, like this is PM7150, and you have seen this is a VBAT. There is a boot cap, right, the VPH generate and the coil. So this IC work as a charging. The other IC near the CPU, SMB or something, S2U or SMB, whatever, the IC work as a fast charging IC. The coordinate both. We will explain each and every line with the whole detail in our course, right? How these IC coordinate with each other, which IC activate first, and after that move on to the step by step, right? So it will be a help you in a diagnosis. So basically I want to say this IC, we have to check this IC step by step, and after this we go to the further. Now one thing common, or you can say one thing, remember, there is a no buck voltage on this. If there is a no buck voltage, there are many reasons, but one of the reasons, like a VPH. But if VPH is drop, if VPH is made, if VPH is not connected, like I will explain you, like this IC EMU 7150. Now this IC generate a VPH. Now VPH is a primary line, also goes to the many ICs. Before, on a single PMU, the charging IC generate the VPH and give it to the PMU. Now this PMU also generate the buck lines. It same goes to the like a VBAT, right here, like a VBAT, and also VPH goes to the this IC and generate the buck, right? Also the LDOs. Now the VPH, this IC generate the VPH, also the VPH came back to this IC for generating the buck inductors, need the buck, right? For every buck we need a separate VPH. I know some people are confused about this, but in our course, as I told you, we tell you a step by step in a deep detail. Now the 7150, okay, now this is generate the VPH. Now this VPH also goes to the 7150L, also goes to the another IC. But here is comes, now this IC does not generate the buck inductors. Now this IC also does not generate the buck inductors, right? Maybe the chances the VPH had a problem. Due to this IC does not generate, but the VPH had 4.3. That means there is no problem on a VPH, right? Somehow problem in others. There are another line. If this line has a problem, your PMU does not generate the voltages. Which line is this? This is a call a fault. Now this line come from the main charging IC, or you can say the PMU, main charging PMU, to another PMU. If there is a 5 PMU, let's say a 5 PMU, right? Now this line connected to the multiple PMUs, right? So we check this line first, and let me see this line is okay or not. Okay, and we go to the controlling section right here. There TP 4 to 700. Now we do one thing, but we have a bitmap. So we open the bitmap and this one, and open the 30 here in between 2 bucks. So we connect a multimeter, I mean to say we test here a voltage. So we connect a charger. Okay, so we do one thing. The radio is already at a long. no one watch the long video, so I'm avoiding the long video. But still, if you explain everything in bit by bit, the video is long. So we go to the microscope also. Let me do in a microscope. So we check this, okay, 2 3, this one. So we check the connectivity, just this pole to this. So the connectivity is okay. That means our PMU, maybe our PMU does not operate, our PMU does not generate these voltages. So I think our PMU has a faulty. Replace this IC. This is a motherboard. We have found this IC. So we 7150. I will show you in a microscope. So we replace. Okay, so we replace this IC, and I will meet you after. I will cut the video here because this video is already long, and after reballing the video, I mean to say. So we just revolve the IC here. We just revolve the IC. Maybe this ball is dropped. Okay, now we have revolved the IC. Now we place this IC, and this one is old IC. Now we check the direction on this side, on this side. All right. Like this. Okay. Now we place the IC right here, and after cool down we check the phone voltages. If this work come on my table without recording, I will done in 15 to 20 minutes max with all diagnoses, maximum half an hour, right? But when you explain each and everything bit by bit, you have to time in a detail. Also handle all the equipment. Sometimes if one equipment doesn't work, then we reboot the equipment. So there are plenty work when you explain, I mean to say. So basically, if this work come to my table directly, right, without recording, I will done this work on a 15 to 20 minutes max. Probably it's in half an hour, take half an hour. But when you explain something, right, in a deeply, that time there is a time consuming. This one is a time consuming process. Actually, teaching is a time consuming process, because when you explain or when you handle while the recording, sometime a single tool off, sometime another tool off, so reboot the tools sometime all the times. So that will be the hard point, right? Now we connect here and we connect the charger here. Now we check the buck lines, 0.8, 0.8, 0.7, 1.1 on this, 0.8 stable on that PMU, 0.6 stable, and on this buck this is maybe a VPH, 0.8 stable, 0.6 okay, 0.6 okay. So all the bucks are generating a voltage, and this one is a okay, all the buck giving me a voltages. So phone turn on, maybe an issue. Okay, the phone turn on properly. Okay, now the phone working well, charged properly, right, and turn on. Before there is a issue related to before it's in a dead condition, right, no buck generate. Also the two capacitors related to the camera driver IC is short. When we remove the camera driver IC, right, the shorting clear, but the phone does not turn on. When we check step by step in a diagnosis process, when we go to the schematic and according to the schematics, due to this phone does not generate the buck, the output lines. When we replace the PMU, when we check the connectivity is also okay, but the voltage is missing. So when we replace the PMU, the phone turn on properly, right, and it's working fine. So it's working fine now, right? Due to this, the phone does not turn on, but now the phone turning on when we replace the PMU, the fault resolve. Now I will give you some tips, or you can say the class, a theory class, how to diagnose a phone which has in a dead condition come to you, right? Now let's suppose a phone come to you in a dead condition. Always work according to the IC. As you seen in this video, there is no schematics, right? Also there is a 2 PMU phone, but if you know how to tackle or how to diagnose the phone, if there is no schematic, still you help with the other phone, the other model schematics, and you can diagnose this phone, right? Now whenever a phone come to you, the mostly technician, or you can say the international, I will talk to, right, the some technician stuck. So whenever a phone come to you in a dead condition, now some technician stuck, or you can say confused related to the VBAT. They directly check on a VBAT line, means a voltage on a battery connector on a positive line. Because they think if there is a no voltage, this phone in a dead condition, right, due to this. But I will tell you, this is not the correct way. Whenever a phone come to you, the most, right, so first thing, confirm if the phone in a dead condition or related to the charging issue, right? Because if your phone has a no charging issue, right, the customer give you a phone, but before it's a not charging, it's a give you in a dead condition, the phone does not turn on due to battery low. When you connect the DC, sometime the boot cable does not match and give you like a 30, 40 and back to 00 reading. That time you think there is a PMU related issue, secondary line issue, right? These kind of the thinking. But in reality, when you connect a battery, charge the battery in a manually, and or the battery BMC strip connect with the DC power supply, the phone turn on properly. Now there is a charging related issue. Due to this, the battery low. Now this is a different scenario, right? Now in a dead phone, or you can say the phone does not turn on, there are multiple reasons, from software to hardware, from PMU to CPU, from charging IC to any IC, from shorting, leakage, there are many things. So there is a process to diagnose, right? So I will share with you some tips or how to diagnose, right? So we clear this. So first of all, whenever a phone come to you, in a dead condition. Do the basic things like the bed, charge the battery and check. After this, you have to check first of all, right, with the multimeter, right, on a positive line. If you had like a 350 plus, right, a 350 plus, and on a reverse bias with the black probe on a battery connector on a positive and the red on a ground, and 1000 plus reading on a forward bias with the red probe on a battery connector and black on a ground. It means when you flip the probe, if you had this type of the reading, according to the multimeter, this phone is okay, right? There is no shorting. It doesn't mean this is okay, there is no shorting. But if you get, let's say, a 350 on a reverse bias with the black probe on a battery connector, red on ground, and when you flip the probe with the red probe, you have a 700, 600, 350, like this kind of the reading, that means there is a half shot. Or when you have a 0, 0, 0 on a both direction, that means there is a full shot, right? The shorting part is the simplest part. You can easily diagnose, right? Now talk about this. Let's say the multimeter part is okay. After you have to connect a DC power supply. Now I'm already made a DC power supply video, and DC power supply gives you a huge edge on this in a diagnosis, right? It will be help you a lot, right? Through DC you can predict which section had a faulty. There is a programming related fault, there is a secondary line related fault, there is a leakage, shorting, right? So according to the video which I made, right, you have to watch this. You can think there is a fault, right? We always try to diagnose with the multiple tools, as I told you. Number 3, you have to diagnose with the USB ampere charger. There is also a reading, right? I will soon make a video on this, as I told you. Now after this testing, you have to check the VPH for voltage, right? If there is a right voltage, then we go to the further. If there is a no voltage or voltage fluctuation, in some cases you will get a fluctuation, but when you connect the battery, the voltage must be stable, right? But if still there is a no voltage or full voltage fluctuation, then you have to work on the charging IC, or any case there is a 2 PMU or 3 PMU, 4 PMU, the main charging IC inbuilt in like a main PMU, or which PMU inbuilt in a main charging IC, you have to work on this. Your first job, stable the VPH, generate the VPH. If the VPH is okay, you have to also make sure the VPH connected with the all points to the all PMUs, right? Now let's say this is a VPH. Now VPH connected to the multiple points. Now there is a thing, if VPH does not generate, your PMU does not boot, right? PMU does not generate the outputs. But if the VPH is generate, you will get a voltage on a VPH, but some point like this point is does not connect, all other points are okay, then the buck line is in a fluctuation, because this VPH for every buck has a own separate VPH like this, right? So any buck does not has an input, it does not generate, and the CPU does not hold the and the CPU does not gives you a PS hold signal. So all the bucks are fluctuation. Now another line. Now in a box time, when you check the box section, clear this, when you check the box section, there are 3 or 4 type of the condition. First condition, voltage not generate, no output on buck. So there is a different process, right? Number 2, buck line, all buck voltage, all buck line voltages are fluctuate, right? There is a different process to diagnose this. Now all buck stable means when you check all bucks are like a 0.8, 0.8 stable voltages, but phone still does not turn on, right? Phone still in a dead condition. Then how to diagnose? Now in a fluctuate, it's like 0.6, 0.1, 0.3, like this situation. The voltage fluctuate and the phone in a dead condition. Now there is a no voltage. So there is a process. After buck, there are multiple steps, how to check protocols, how to check controlling section all, right? So if you want to know the process and if you want to know how to diagnose a step by step, and if you learn about the schematics, how to read schematics, how to work according to the schematics, join our online classes. We'll give you all detail about the schematics, about the each and every line with the process, right? So we will meet you in the next video. And remember one thing, before going, there is an offer. If you grab this opportunity, right, you have a 3-year right now. After end of this month, right, finally after end of this month, only for the 1 year subscription update validity. So grab this opportunity, right, and make your level increase, start your journey for the success. Thank you so much. We will meet you in the next video. Thank you.